Okay, we're going to start our newest unit on trigonometry. We have 2 units left. Probability will follow after trigonometry, and this will take us a few weeks. And for some of you, it'll be completely new information. We are going to start off the unit by looking at radical operations and also learning how to rationalize the denominator. Some of this is going a little bit beyond what is in Common Core 2 as of now. But it is what used to be in Algebra 2 and Geometry. So it's little things that you should know how to do, and I think you'll feel more comfortable going into upper level math courses, at least knowing the basics, and that's all we're going to do is the basics, nothing major. You should have already done the first 6 while we were setting up, and this was simply just using the Pythagorean theorem, making sure that you remember how to simplify radicals. So for the first one, you should have simplified 9 plus 16 equals x squared, so that 25 equals x squared. When you take the square root of a x squared function, remember that you are not going to get just the principal square root of 5, but you're also going to get the negative square root. So you'll get the positive and negative 5 as your x. X squared plus 16 equals 25. When you subtract 16, x squared equals 9. Taking the square root, you're going to get x equals positive and negative 3. 25 plus x squared equals 169. X squared is 144. So you should have positive and negative 12. For the next one, 9 plus x squared equals 16. X squared equals 7. So that x equals the positive and negative square root of 7. And you can't simplify that since 7 is prime. 16 plus 49 equals x squared. 65 equals x squared. Take the square root of both sides. Positive and negative square root of 65 equals x. And the factors of 65 are 13 and 5. So because they're both prime and they don't share any factors, square root of 65 is simplified. X squared plus 25 equals 100. X squared equals 75. So x equals the positive and negative square root of 75, but we can simplify from there. 25 is a factor of 75, and 25 is a perfect square. So if you knew that, you can just pull out the square root of 25, which is 5. If you need to, remember, you can always kind of break it down to this prime factorization. 3 times 5 times 5, and for every pair you can pull out 1. So you'd have positive and negative 5 square root of 3. We're going to kind of move between pages 1 and 2, because I originally wasn't planning on having you rationalize the denominator, but now I do want you to. So we're going to do most of the front. We're going to flip to page 2, and then we're going to come back and finish up the front. For number 1, or actually 1 through 9, we're looking at basic radical operations with addition and subtraction. And the main idea here is very similar to whenever you first started simplifying expressions with variables. 3x plus 5x equals, let me start over, 3x plus 5x minus 7y. You could only combine the 3x and the 5x to make 8x, and you still subtract the 7y. You can't combine radicals unless they have the same exact radicand, which is the number under the radical symbol. So thinking about this one, it's kind of like saying 3x minus 4x, which is negative x. Well, this is the exact same thing. You have 3 square root of 6 minus 4 times the square root of 6. So you're going to have negative 1 square root of 6. And of course, you don't need to put that negative 1 coefficient. This is very similar to saying negative 11x minus 11x, which would be negative 22x. Since we're not using x, we're using the radicand negative 21. They have the same one. You would just subtract your coefficients. Negative 11 minus 11 is negative 22 times the square root of 21. For number 3, they both have square root of 15. So I have negative 9 plus 10 is positive 1. So you have 1 times the square root of 15. Take a minute and complete number 4 and 5. For number 4, they have the same radicand, square root of 7. So I'm going to add my coefficients. Negative 10 plus 12 is 2 times the square root of 7. Same radicand. Negative 3 minus 4 is negative 7 times the square root of 17. Looking at number 6, when you first look at it, it does appear as though, oh, it's already simplified. I'm not going to be able to do anything. But make sure that your radicand is in simplest form before you automatically assume your expression is completely simplified. For instance, square root of 18. 18 has a factor of 9, a perfect square. So I can pull that out. I'm going to show it in several steps. I know you may not need to show all of this eventually, but just to make sure everybody's on the same page. So from here, square root of 9 is 3. So I'm going to pull that 3 on the outside and multiply it by the coefficient that's already there. So I'll be pulling a 3 on the outside. 3 times 3 is 9. So my coefficient is now 9, leaving me with 9 times the square root of 2 minus 2 times the square root of 2, which then we can easily simplify to 7 times the square root of 2. Number 7, 18, 8, and 24. And actually, all of these can be simplified. So square root of 18 has a 9 in it. So the square root of 9 is 3. So I'm going to bring a 3 out and multiply it by the negative 3 that's already there. So I'll have negative 9 square root of 2 plus this is 4 times 2. So I can take the square root of 4, which is 2, and multiply it by 3. 3 times 2 is 6. I'm left with the square root of 2 underneath, minus 24 has factors of 4 times 6. I can take the square root of 4, which is 2, and that leaves me with a radicand of 6. And the factors of 6 are 2 and 3, so there's nothing further that I can pull outside the radicand, or the radical. From here, I can only combine these. It's like saying negative 9x plus 6x minus 2y. Can't combine x's and y's through addition and subtraction. So negative 9 plus 6 is negative 3 times the square root of 2 minus 2 times the square root of 6. I'm going to give you a minute to try number 8 and 9. For number 8, the square root of 18 is the same thing as 9 times 2. The square root of 9 is 3. 3 times 3 is 9. Times the square root of 2 would be left. 12 has the perfect square 4 times 3. When I pull it out of the radical, it's 2. 3 times 2 is 6 times the square root of what remains, 3, plus 27 is 9 times 3. Square root of 9 is 3. 2 times 3 is 6. Square root of 3. Can't do anything with this one because it's got the square root of 2 and neither of these terms have that. 6 square root of 3 plus 6 square root of 3 is 12 times the square root of 3. For this one, I have negative 3 times the square root of 5. I can only combine it with this one minus the square root of 5. Negative 3 minus 1 is negative 4. Square root of 5 minus the square root of 6. So that's about as far as we'll go with addition and subtraction. Just remember, it's like adding and subtracting variables. You can only combine the radicands, or the coefficients of the radicands that are the same. All right, we're going to do 10 through 17, and then we'll come back and work on 18 through the remainder after we talk about what to do in the denominator. All right, so for number 10, this is a little bit different, multiplication and division. Unlike addition subtraction, you guys know I can do 2x times 4y. They don't have to have the same variables. This is one term. It's just unsimplified. I can simplify it by multiplying the coefficients 2 and 4 and then tagging my variables along at the end. Same idea here. I can multiply this. This is simply one long string of multiplication that I can separate using multiplication symbols. I have 4 times the square root of 6 times the square root of 6. You have two options. Since it's the same radical, square root of 6 times the square root of 6, square root of 6 times the square root of 6 is 6. If you need to see it, you can think of it by multiplying the radicands. Square root of 36 is 6. I would hope that eventually you know square root of 6 times the square root of 6 equals 6. And I think you probably will see that more and more as we go through the Pythagorean theorem tomorrow. For this one, you have two options again. One of the ways is just to go ahead and multiply your radicand. So I have negative on the outside. 2 times 20 is 100. And then the square root of 100 is 10. And then a negative. Now, it's not equations, so it's not positive and negative. It is negative because we started off with that opposite, that negative square root of 5. What I have seen some people do is they'll simplify this, because this is 4 times 5, which is the same thing as 2 times the square root of 5. And then I have a negative. Square root of 5 times square root of 5 is 5 times that 2. So you'll get the negative 10. There's different ways you can go about these. Number 12 is pretty simple. I'm going to keep the negative. And then I have square root of 2 times the square root of 3. So underneath I would just put 2 times 3, which there's not much I can do there. It's just 2 times 3, which is 6. So it's negative square root of 6. For 13, you could simplify and bring out that perfect square of 4, or you can just multiply. 4 is my only number on the outside, times the square root of 8 times 2 is 16. Square root of 16 is a perfect square, so it's 4, so it's 16. For number 14, you could go ahead and multiply 12 times 15 and put that under the radical, and then you'd have to do some simplifying. Whenever numbers start to get a little bit bigger, I find, especially if I don't have the use of a calculator, that I don't want to have to work too hard or work as hard once I have a big number. So one thing I try to do is break it down into factors. I try to find perfect squares. That doesn't always work, so I try to also find partners. So 12 has a 4, so that's perfect square, so now I can do something with that. And it's 4 times 3. 15 has the factors 3 and 5. So I know the square root of 4 is 2. And I have a set of 3, so I can pull one of them out. And that leaves me with the square root of 5 underneath. Since I pulled out 2 and I pulled out a 3, I have to multiply those to make my new simplified coefficient of 6. And then the 5 didn't have a partner, so it stays underneath. For number 15, again, it's just a string of multiplication, so you can kind of change the order if that makes it easier for you to visualize. Square root of 5 times the square root of 5 is 5. 5 times negative 2 is negative 10. Number 16, I know I can't simplify the square root of 10, but I know I can simplify the square root of 8. It's kind of up to you how you want to go about it. I'm going to go ahead and just multiply 8 and 10. So at this point, you can break it down into 2's and see how many pairs of 2's you have. You know it's 4 times something, or 4 times 20. equals 80, but then you got another 4 in 20. So if you wanted to, you could just say negative 4. That's 4 times 20. 20 is 4 times 5. So there's my pair of 4s. I'm going to pull a 4 out and multiply it by this negative 4. So it becomes negative 16 square root of 5. And last but not least, I'm going to do number 17, which looks a lot like number 14. So I have 2 on the outside and 4 on the outside. I'm going to multiply those coefficients and get 8. I'm actually going to copy up top because I know 12 is 4 times 3 and 15 is 3 times 5. So I can pull a 2 out and I can pull a 3 out. And then I'm left with a square root of 5. Now, just keep in mind, I just did 2 different things. 4 is a perfect square, so I took the square root and brought that 2. 3 in pairs would be like me writing a 9 underneath and taking the square root of 9 to get the 3. Then I can multiply these things, so that would be 8 times 2 is 16. 16 times 3 is 48 times the square root of 5. We're going to stop there on page 1. And actually move to page 2. We'll come back. I just want to make sure, originally I had not planned on having you rationalize in the denominator and then change my mind. So we're going to come back and make sure we do these the proper way.